Hey guys, this is Mr. Filsick. I'm just shooting this video so we can go over a few vocab words you need to know, as well as a few of the periodic trends we talked about yesterday that you really need to know in order to do well on this unit's test. So vocab you need to know. First off, period versus group. I'm going to reiterate this a lot because if you don't get it now, you're going to be confused later on. A period is just the horizontal row in the periodic table. So in this case, in this picture, of course, it's just like the green row here, then the light blue, then the dark blue, right? Each one's a period because it's a different distinct row. A group, however, is what we call the vertical column. So in this case, the red column, the orange column, the yellow column, the green column, etc. So periods horizontal, groups vertical. Reactivity is just how quickly an element or a substance reacts, how easily it reacts, right? And we said if something's more reactive, it's going to be more likely to have a bigger visible reaction, like an explosion or a fire, something like that. Atom. The matter is broken up into really small pieces. The smallest piece of matter you can possibly have is an atom. All these elements we're learning about are simply different types of atoms. We're going to learn much more about this in the coming days. And lastly, atomic mass is just the mass of the atom. This is listed on the periodic table under each element. It's normally a decimal number. We'll explain why it's a decimal, not a whole number, later on as well. Periodic trends you need to know. This hopefully will be a review for a lot of you. As we read from top to bottom, a big trend you're going to notice, guys, is that the elements increase in mass as you go down this way. You're going to see the decimal number in the periodic table gets bigger and bigger as you go down. In other words, hydrogen is going to have a mass of approximately 1. As you go down here, the mass is going to get bigger and bigger and bigger until francium down here is going to have the biggest mass in that column from top to bottom. As you go from top to bottom, all these elements are going to react with the same substances. For example, these elements in this column right here in group number 1, hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium, they all have something cool in common, and that they all like to react with the same substance. The substances they like to react with are the halogens over here. So these guys. So you have fluorine, chlorine, bromine, iodine, etc. They like to react with these guys. Lithium, for another example, guys, these guys in group 1 will never react with the elements in group 2. We'll learn about why that's the case later on as well. Also, if they're in this from top to bottom, guys, they're going to also have the same number of spokes. Obviously, you know all these guys in this group all have the same number of spokes. These all have 1, these guys all have 2, these guys all have 3, etc. And they all form compounds in the same ratio. What that means is that whenever lithium, sodium, potassium, rubidium, cesium, or francium combines with one of these halogens over in this column, it's always going to combine in the same ratio. I mean, it's always going to be 1 lithium matched with 1 fluorine, or 1 sodium matched with 1 fluorine, or 1 potassium matched with 1 fluorine. However, if any of these guys pair up with, let's say, one of the elements in this column, it's always going to be 2 lithiums to 1 oxygen. So Li2O, or Na2O, or K2O. So they always the subscripts that I'm hinting at there are all indicate the ratios they combine. So it all boils down to this, honestly, right up here, guys, that they react with the same substances. So as long as you know that, you should be good to go. As you go from left to right, of course, this one trend that we saw is the number of spokes increases. We'll talk about what that means in a little bit. It also goes from solids to gases. So as we look over on this side of the table, you're going to see a lot more solids. This side of the table, you have a lot more gases. And obviously, there are a couple exceptions in there, but that's pretty much stays true for the most part. Of course, guys, in every family, we have that awkward person or two. In our periodic table, the awkward person who's kind of weird, whatever. There are actually 2 of them. It's hydrogen and helium. Okay, they kind of don't really fit in anywhere. So they're placed where they are for certain reasons. We'll explain why they're placed there later on. But just know that they don't really follow the molds as the other elements, right? Like all these elements over here are all metals except for hydrogen, right? So he's like that weird guy. The reason he's over here is because he has 1 spoke, so he fits in on this group 1. But he is a non-metal, so he kind of relates to these guys over here. So keep that in mind. Lastly, guys, of course, it increases in atomic mass as we go across. So potassium right here is going to have the least atomic mass, then calcium and scandium will have more, titanium will have more, vanadium will have more, etc. Lastly, guys, the trend, it's the trickiest one I always say is the reactivity trend. It just says that elements on this side, as you go down the table, become more reactive. Elements on this side, as you go up the table, become more reactive. In other words, like it's this corner that's really reactive. These elements in this corner, so cesium, rubidium, strontium, barium, etc., are all going to be very reactive. Means when they combine with other substances, a lot of times they're going to be more explosive or whatnot. So this corner and this corner is the same way. The obvious exception is this purple row right here, the noble gases. The noble gases, of course, as you learned, are always unreactive. We'll learn why they're unreactive. I'll give you a clue. It has to do with the fact that they have 8 spokes, but we'll learn about that in a little bit. So these two corners are the most reactive. So this trend, elements get more reactive from top to bottom on the left and more reactive from bottom to top on the right. Go ahead and answer your questions. If you're happy with your grade, you can go ahead and submit it, and you're all set.